let's take a look at zeros and factors of a polynomial and how they relate to one another. We will start with zeros, and this is a tricky one because 0 is a number. This is not that same thing. This is a0. What is a0? So let's define that. A 0 of a polynomial is a value, a number, let's say, that can be substituted into the polynomial to make the value or number of the polynomial, the entire polynomial, 0. Okay? That's a very wordy way to say it, but it's very simple. So the idea is if I plug this number, this what we're going to call a 0, into the polynomial, then the entire polynomial, the value of it is 0. Okay? So just to illustrate this with examples to see how simple it is, I have some polynomials down here, and let's look at those and start understanding their zeros. Okay, so this first polynomial, x squared minus 2x minus 15, I'm not telling you how I know this, I'm just telling you that negative 3, excuse me, negative 3 is a 0. Negative 3 is a 0. This number is a 0 because if I plug it into the polynomial, I get negative 3 squared minus 2 times negative 3 minus 15, which is, well, 9 plus 6 is 15, minus 15 is 0. So the key is the value of the whole polynomial becomes 0. So negative 3 zeroes out this entire polynomial. So negative 3 is a 0 for this polynomial. The second one, by the way, let me back up. This first example, there are other zeros as well. And typically, the degree of the polynomial will tell you how many zeros, basically. So you would expect 2 zeros for this first polynomial. As we'll see soon, some of the zeros may repeat more than once and be a 0 multiple times, okay? So this next one you would expect like 3 zeros, okay? And specifically, 1 is a 0 because you can guess if you plug 1 into this polynomial, you get 1 minus 4 is negative 3, minus 1 is negative 4, plus 4 is 0. So 1 zeroes out this polynomial. Okay, this last one, just for good measure, we could see that negative 1/2 is a 0. Not quite as easy, right, when you're not dealing with whole numbers. Zeros, in fact, can be whole numbers. They can be 0. They could be rational numbers, meaning fractions. They could be negative. They could be positive. They could even be complex numbers using I. They could be irrational numbers like the square root of 2. So I'll show you examples of that too. Okay, so negative 1/2 is a 0 because 6 times negative 1/2 squared minus 5 times negative 1/2 minus 4 equals 0. Well, let's check that out. Negative 1/2 squared is 1/4 times 6 is 6/4, or 3/2, plus 5/2. So I have 3/2 plus 5/2. That's 8/2, which is positive 4, minus 4 is 0. Okay, so just real quick, let's look at a couple other examples, such as x squared minus 2. In this case, the square root of 2 is a 0. If you plug square root of 2 in for x, you'll get 0. x squared plus, let's do this, x squared plus 1, I, the complex number I, is a 0. I squared plus 1 equals, when you square I, you get negative 1. Negative 1 plus 1 is 0. So I is a 0. So I just want to show you an example of an irrational number, these square roots that aren't very nice, and a complex number that are zeros as well. Okay, very good. Now, we understand what zeros are. Let's see something else. I'll move these examples out of the way, and I'll define what a factor is, and then we can look at the relationship between zeros and factors. Okay. So, in general, a factor of a polynomial is a quantity that can be multiplied by something, by another quantity, to get the polynomial. For example, before we looked at x cubed minus 4x squared minus x plus 4. This is the same thing as, a different way of writing this is x squared minus 1 times x minus 4. And the point here is not to teach you how to get this. I'm just showing you this is the same thing. If you multiply this blue stuff out, you get this polynomial. The key is these two things multiply together to give me this polynomial. So in other words, x squared minus 1 is a factor, and x minus 4 is a factor. Okay? So that's what factors are, things that multiply together to give you the polynomial. Now, we would like to limit our factors, what our factors are, to linear. So a linear factor is a factor, so just like above, but it has a degree of 1. Linear means degree 1. So if we go back up here to this example, x minus 4 is a factor, and it's linear because x here is to the first power. X squared minus 1 is a factor that is not linear because the degree is 2. Okay? So we're going to try and get linear factors when we look at polynomials. Okay, very good. So that's what factors are. We're almost done. Now let's start looking at the relationship between zeros and factors. So let's look at this x squared minus 2x minus 15 again. This, if I were to factor it, another form of this polynomial is x plus 3, x minus 5. Now look, if I'm trying to figure out how this entire polynomial would equal 0, then that's the same thing as knowing how this entire polynomial would be 0. Well, the one on the right is very easy. If I want x plus 3 times x minus 5 to be 0, then, well, the idea is if I multiply two things to get 0, one of the two things has to be 0. In other words, one of the two linear factors has to be 0. So we can conclude that x is -3 or x is 5. What we're saying then is that -3 and 5 are are zeros of x plus 3 times x minus 5. Or, that's the same thing as x squared minus 2x minus 15. Okay, so what's the point of all of this? Would you rather find the zeros of the polynomial when it's not factored, or would you rather find the zeros of the polynomial when it is factored? Well, we like the factored form, because if it's factored, each linear factor will give us a 0. Each linear factor gives us a 0. So if we know the linear factors, we know the zeros. Right? X plus 3 is a factor, so -3 is a 0. X minus 5 is a factor, so positive 5 is a 0. A 0 is what it takes to plug in to make the whole thing 0. So -3 and 5 are zeros. And they're the only zeros. There are no more. Again, this has a degree of 2, so you can't have more than 2 zeros. Okay, let's look at another example. And let me work it out on paper here really quickly. Okay, so this one's pretty easy. X cubed plus 2x squared plus x. What are the zeros of that? You would expect 3 zeros. If we can factor this, then we know it's zeros, if we can factor it into linear factors. Well, if you factor this, what you're going to get is x times the quantity x plus 1 squared. So we have two linear factors. We have x, that's a linear factor, and we have x plus 1, that's a linear factor. X plus 1 squared, by the way, is just the same thing as x plus 1 times x plus 1. Okay? So what we have is each linear factor here is going to give us a 0. So if x plus 1 is a factor, what we can say is -1 is a 0. If x is a factor, people always get confused by this. Let's go back to the x plus 1. Where does -1 come from? Well, it comes from, if I set x plus 1 equal to 0 and solve for x, then x equals -1. So over here, how do I figure out it's 0? Well, set x equal to 0, and x is 0. So 0 is a 0. Okay, don't let that confuse you. The number 0 is a 0 of the polynomial, meaning if I plug 0 in for x, this entire polynomial becomes 0. Okay, but we have x plus 1 twice, so -1 is a 0 twice, and you could tell that in this form because x plus 1 is squared. So what that means is -1 is a 0 with what we call multiplicity two, because -1 is a 0 more than one time. It's a 0 twice. 0 is a 0 with multiplicity one. Let's use the word 1 here. So we have this new term, multiplicity. So this polynomial you would expect to have 3 zeros, but in fact it only has 2 zeros, 0 and negative 1. However, negative 1 is a 0 twice. It has a multiplicity of 2. Alright, one last relationship here. We know that if we have factors, so linear factors, give us zeros. Remember, something like if x plus 1 is a factor, then negative 1 is a 0, for example. Okay? So that's what we mean by this. So this is an example. But also, zeros give us linear factors. It works the other way. For example, if negative 1 is a 0, then we know that x plus 1 is a factor. So here's an example, okay? Consider x cubed plus 1. We don't maybe know how to factor that. But notice negative 1 is a 0. Because negative 1 cubed plus 1 equals 0. What we just said from this guy here, from this statement, if we know a 0, then we know a factor. So, x plus 1 is a factor of x cubed plus 1. So what does that mean? Well, I don't know how to factor. I do know how to factor x cubed plus 1, but it's not obvious. But I do know now very simply, because I knew negative 1 was a 0, x plus 1 is a factor, meaning that if I were to factor x cubed plus 1, it would be x plus 1 times something else. That's what it means for x plus 1 to be a factor. It would multiply by something else to give us x cubed plus 1. So I know that if I wanted to factor x cubed plus 1, x plus 1 would be a piece of that factoring process. Okay, so that's zeros and linear factors. If we know zeros, then we can get linear factors. If we know linear factors, then we can get zeros.